Hi, good afternoon. My name is Luís Carvalho, and I'm Defense and Security Business Development Manager at INOV. First of all, I would like the opportunity to present here, and I would like to specifically say thank you to our long-term partner ITML that invited us to perform this presentation. Today, I will present the technologies that INOV developed within a research and development project named 7SHIELD. So, very brief looking to the agenda that I'm proposing. At first, I will present you to INOV, taking INOV at a glance look into it, and then I will go on a brief overview of the 7SHIELD project. And on the later stage of the presentation, we will get into the technologies that was developed by INOV in the 7SHIELD framework, namely the Multi Modal Automated Surveillance system and the first responders support system. So, INOV is a leading Portuguese research and technology organization. We work in the area of ICT and electronics, and we work in several domains within it, namely from cyber physical systems to artificial intelligence, remote monitoring and surveillance, cybersecurity and cyber defense, enterprise computing, and also communication networks and services. We are in Portugal recognized as a technology and innovation center. This is a recognition that RTOs can apply for in our National Innovation Agency, and in the beginning of last year, INOV was recognized as such. We are part of INESC, which is the biggest group of research and development institutes in Portugal, but I will go into a little bit more detail in my next slide. We perform technology development, but also systems integration, testing, and technology transfer and operational support of advanced solutions for private and public clients. I'm used to say that we are in between academia, because in fact we are related to universities, but we are not a research center of a university, and also we are very close to our clients, so that might be private or public ones. So, looking into our network, as I told you, INOV is part of INESC, which is the largest research and development group in Portugal. INESC was founded in the 80s, and in the late 90s, it was decided to be split in 5 different institutes, INOV being one of them. And related to the innovation cycle. So on a later stage, if we look into the TRL maturity level, the other ones are 2 based in Lisbon, as we do, which is INESC-ID and INESC-MEN, and the other 2 organizations are on the northern part, INESC-TEC in Porto, and in between Porto and Lisboa, we have INESC-Coimbra. As I was told, INOV, and through its shareholders, indirectly through INESC, we are very close to academia, because several universities in Portugal are our main shareholders, and we are and have a very good relationship with Instituto Superior Técnico, which is based in Lisbon. On the other hand, some private organizations that, when INESC was founded, were also public entities are now our shareholders, namely Altice Portugal, and the CTT, which is the Portuguese Postal and Carrier Service. INESC, the group, also is also a shareholder in several companies, some of them that are spin-offs that evolved from the research and development activities. On the bottom side, you can see on the left several organizations that INOV is involved in, and on the right side, international and mainly European ones, such as EARTO or EACTDA, or the more recently found EDRIN, which is the European Defense Research and Innovation Network. Research and development is on our origin, and we have extensively experienced it in large national and European research and development projects. And in the last decade, we have over 70 participations, including coordination roles, some of them projects that we are coordinating currently. We are the main private institute in Portugal in the areas of safety, security, and defense. And due to that, we have relevant and important partnerships with the Portuguese Ministry of Defense, as well as with all of the armed forces branches, and naturally also with our police forces. On the other hand, we are also very close to our national and European SMEs. Internally, these activities are performed within our research teams. We have three: one focused on interface and co-creation, the other one in cybersecurity, and last one in electronics monitoring and control. And they have naturally different focus areas, such as digital fast and power electronics, or product engineering, LiDAR and hyperspectral imaging and image processing, IoT and remote monitoring, navigation and positioning, and also data analytics and decision support systems in our electronic monitoring and control area. And the cybersecurity one focus naturally in governance, risk and resilience, assessment and compliance, cryptography and blockchain, intrusion detection, and privacy. And in the last one, we have the communication networks, the IoT systems and applied information systems, and digital transformation and collective intelligence. And all of this research and development work is naturally mapped in several projects. Here I present you some of a short representation of several projects that we took part. I think here we are ranging from the European Union FP7 program until the current Horizon Europe, some in different domains, some to which we coordinate, like the Irish project. And I did not had here, but we have also several running projects in the European Defense Fund. But I decided to skip one of them here naturally, because I will present its logo in the next slide. Obviously, it's 7SHIELD, and this is the project that brings me here to speak to you about what we developed within 7SHIELD. In this case, 7SHIELD was an Horizon 2020 project. Submitted a proposal to the call Infra01 on prevention, detection, response, and mitigation of combined physical and cyber threats to critical infrastructures in Europe. And it ran between September of 2020 and February of 2023, with a total budget over 8.5 million euros. And 7SHIELD focused on the safety and security standards of space systems, namely its ground segments and satellite data assets, and covered both the prevention, the detection and response and mitigation, and related technologies against physical and cyber threats. The consortium was composed by 22 organizations from 12 European countries, and it was led by the company Engineering from Italy. The goal of 7SHIELD was to develop a flexible and holistic security framework covering all macro stages of crisis management, so the response, detection, detection, response, mitigation, and prevention, in order to protect European ground segments infrastructures against both physical and cyber threats. And its framework integrated several cutting-edge technologies arising from several disciplinary fields and complementary ones that was then classified through 7 main thematic categories, namely IoT, decision support systems, semantic reasoning, high-level analytics, crisis management, sensors technologies, and also situational awareness. Now I will give you an overview of the project and what it covered. So if we start from the bottom and looking into both the physical and the cyber threats that are are threatening, in fact, the ground segments of space assets, the project aimed to cover all the all the macro stages of the crisis management cycle, and starting from the bottom left, the prevention. So on the prevention side, some technologies that were developed in the project with the goal. With several goals, namely to estimate and classify risk assessments and vulnerabilities, promote secure authentication mechanisms for accessing the data, preventing cascading effects from physical and cyber threats, and also generate cyber and physical threat intelligence. While during the event for the detection, data acquisition and pre-processing methodologies were aimed to be developed, and also video surveillance technologies for physical attacks, innovative laser-based technologies for the detection of ground-based and aerial attacks, and also the combined physical and cyber threat detection and early warning. Then if you look to the response stage, it focused on the semantic representation of reasoning and decision-making, crisis level classification for multimodal data fusion, decision support mechanism, social awareness and interaction with the citizens, and also neutralization of intruding UAV. And finally, regarding the mitigation stage, development of services for continuity scenarios for both cyber and physical attacks. And all of this was integrated in a 7SHIELD platform with the proper data models for the combined detection, and naturally the required user interfaces and command and control softwares. These technologies were mapped and several use cases were defined and requirements for the critical infrastructure operators, and several pilots were designed and implemented to test the methodologies developed within the project. And the pilots were developed and implemented between October of 2021 and December of 2022, and there were 7 of them lying in between 2 categories. The first one was the operational trials that were held in between October of 2021 and May of 2022, and then when the technologies were a little bit more mature, starting from September until December of 2022, the final demonstrations were held in Athens, in Finland, and also in Belgium. 7SHIELD key results. The framework of 7SHIELD integrated 20 key results, meaning 20 technology bricks that have been developed and refined during the entire duration of the project, and were submitted to evaluation and improvement and testing during the pilot's operational tests and demonstrations. They were split in between 5 categories. The first one are related to the crisis management stage, the prevention technologies, detection technologies, in which the key result 09 was led by INOV and was related to thermal and near-infrared image processing for man-made threats. Then we have the response technology, in which the key result 14 was also the one led by INOV on tactical decision support system. And finally, we have the mitigation technologies. Besides those, we also have two other key results that were related to the implementation of the 7SHIELD platform and the aggregation of all these technology building blocks. So in this logical architecture, we can see the several layers of the architecture naturally, and all the key results are mapped depicted in the image. We have the cyber physical layer, so in fact the already existing cyber and physical protection systems, and then we have the detection layer for both physical and cyber threats. We have the situational picture layer that generates the information for the critical infrastructure operator, and then we have the service layer, which was in fact the information that operators have access, and in that case they were split in pre-crisis, the response of the crisis, and also the post-crisis stage. Here, the technologies developed by INOV fall under the detection layer, so the multi-modal automated surveillance related to the key result 09, and the first responder support system related to the key result 14 is in this case on the service layer for the response stage. Naturally, as a lot of technology bricks were developed within the project, not all of them was tested and deployed in all the pilots, and they were mapped against all the technologies against the 7 pilots developed within and implemented within the project, and the ones that in the technologies that INOV developed were in the first case the MMAS, the Multi Modal Automated Surveillance System, was deployed and tested in Finland, in the final demonstration in Finland, and the first responder support system was both tested in the National Observatory of Athens pilot, and once again in the one in Finland. And now getting into the technology itself, and it's common to say that an image worth 1,000 words, and as such a video is almost self-explanatory in that case, and I will present you 2 videos regarding the technologies that INOV developed and that were produced during the project 7SHIELD.
The MMAS is a physical detector that communicates with the 7SHIELD with the use of a Kafka broker and also produces a video stream with alarms from a thermal camera. The MMAS is composed by 3 main modules: a processing unit, an operator interface to program and visualize basic features, and a bispectral PTZ camera. The main purpose of the MMAS is to detect possible threats through the use images that are within a field of view of a thermal camera. The detection is made by heat level, movement, and classification. The user interface is composed by several parts: a central video image, which consists of the camera's field of view. Inside, the targets and the alarms can be found in different colors. An image control permits to change the color map of the video, namely bone, winter, jet, or raw. In modes interface, it is possible to change the MMAS mode of functioning between automatic and manual. The manual mode allows to position the camera in a different field of view, using the mouse over the central video area. The mode and the position of the camera, pan and tilt, is shown over the central video area. The zoom can be used changing the position of the thermal zoom control. The detection control permits to activate the alarm algorithms, namely classification, motion detections, and alarms based on the level of heat. All the alarms are sent to the core of the 7SHIELD, then they are filtered and processed in order to detect a threat. The alarms are composed by the identification of the alarm with a small image of the detected possible threat. In this video we can see several targets identified, namely people, deers, and vehicles, with the option classification in the detection zone activated. We can see that the algorithms detect and distinguish the different targets. The objective is to detect the targets in real time with high performance and low percentage of false positives. The MMAS is composed by a video server, which allows other applications to embed the video for visualization of targets and alarms. In here, we can see the VLC program accessing the video server contents with and without alarms. The same happens in a web browser in which we can change the color map. The MMAS participated at the FMI's pilot use case 1. It is one of the tools that improves the detection of possible physical threats, through the use of a thermal camera and image processing algorithms to detect movements and classify entities that are found in an area of interest till limited by the field of view of the cameras. The MMAS provides 2 extra benefits. 1. Considering that during winter the light is very dim in Finland, the use of thermal cameras allows the detection of intruders even during winter. 2. The generation of automatic alarms facilitates the work of security operators and improve the 7SHIELD operation in detecting physical threats.
So this was the presentation of on the MMAS system, and now we will focus and see the video of the first responders support system.
The first responder support system creates a local area network where data flows between the first responders team members. The data is collected by the team leader's equipment and relayed to the 7SHIELD's control center through a dedicated radio data link. Similarly, on the opposite direction, the control center can communicate in real time with the FRSS. First responders teams carry several sensors and auxiliary devices in the form of a tactical vest. The FRSS main technical modules are the processing units and communications in each tactical vest, the biometric and environmental sensors, and the universal tactical display that is only available to the team leader. In this test scenario, a suspicious box was left on the street near an elevator. The mission is previously created with multiple steps and assigned to a team composed by a team leader and 1 team member. The mission is sent to the team already in the field so it can be executed. The main purpose of the FRSS is to support first responders in the execution of their assigned missions, by delivering enhanced information about the mission and the team members to the team leader and command and control center. The team leader interacts with the universal tactical display to see the mission map, live sensor data gathered by the team, and consult the assigned mission with steps and targets. Here we can see the first responders team moving on the map and their real-time sensor data during the execution of the steps of the assigned mission. The UTD has 2 distinct views. 1, where we have access to the sensor's data and about mission execution, and a second view that focus on the mission plan and execution steps. The main element in this view is a map of the site where the mission occurs. This map, besides representing physical elements from the site, also presents to the team leader the position of all team members, and other relevant mission elements sent by the command center, namely, threats and waypoints. On the right side, all team sensor data is displayed in real time. On the bottom bar of the screen we have information regarding the current mission step under execution and a simple 3-button user input and control of the interface. The FRSS will provide several benefits, like real-time communications with the control center and between teams, real-time access to sensors and mission data, low weight and wearable equipment, amongst others. The FRSS was demonstrated at PUC 1 in Finland and at PUC 3 in Greece. Regarding use scenarios, FRSS covers first responders' response to physical threats, improve performance and guidance to teams, and provide mission-related data collection and improve guidance on the retrieval of suspect items.
So these were the two main technologies that INOV developed within the framework of the project 7SHIELD. Thank you for your attention, and now I'm totally available to answer your questions. Okay, it seems that we do not have questions yet. Okay, so if we don't have any questions, I would like to say once again thank you for the organizers and the invitation for INOV to present our technologies developed within the framework of 7SHIELD project. It was my pleasure, and I wish you all a very good continuation of Code Week 2024. Bye-bye. Thank you very much.